Welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper, June 2014. Here we're working on question 5. So the first part of this question looks for us to prove the summation theorem of 2r minus 1 squared equals a third n 4n squared minus 1. So the first thing we do with these sorts of questions is we look to separate the terms of that we're squaring. So expand the brackets inside there, so we get 4r squared minus 4r plus 1, and then we'll separate these into separate summations that we know the formulas for. So the summation of r equals 1 up to n of r squared, and then we need to take away, because take away inside that formula there of 4, and the summation for r equals 1 up to n. And then we add on the summation of r equals 1 up to n of just 1. And then we use our formulas. So the formula for n squared is n over 6n plus 1, 2n plus 1. The next one is take away 4, and then the formula is n over 2n plus 1. And then the last bit here, think of this as 1 add 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 1 n times, which will just be n. So the next thing we need to do here is to think about creating common denominators to make it easy to factorize. And the common denominator that we can pick, that's the smallest out of a 6, a 2 and a 1, is going to be 6. So in order to make a 6 on the bottom of this second term, we need to times the top by 3 as well to make it a 12n. And on the last one here, I'm going to make it a plus 6 over 6n. Why do I do that? Well, it makes it really easy to then factorize. So I'm going to factorize the 6 as a denominator, and I'm going to factorize out an n out of all 3 of these terms. There's nothing else I can pull out. So then I need to think about what I've got to put in my factorised bracket. Now looking at the first term, I need a 4 for the 4n. Already got the n pulled out and already got the 6 pulled out. So all I need here is n plus 1, 2n plus 1. And then for the next second term, I'm going to need to subtract, because there's a subtract on it, 12 and n plus 1. And then for the last one, it's just going to be plus 6, because I've already factorised out the n and the 6 there. So the next thing we need to do is expand this square bracket and simplify down. So 2n squared times 4 is 8n squared. Then I get a 2n, add another n is 3n, times by the 4, I get plus 12n. And then the next one is 1 times 1 is 1, add 4, so times by 4, and yeah, add 4. The next term is going to be take away 12n and take away 12. Don't forget to expand brackets properly, and then add on 6. So some of this looks like it cancels down for me. So I get 8n squared, the 12n and the minus 12n cancel, and 4 add 6 is 10. Whoops, this needs to be a take away 12 from the expanding brackets properly. So it's going to be 10. Take away 12 is minus 2. So I think I said expand the brackets properly and then didn't do it myself. Whoops. Right, okay, so now we can probably follow out a factor of 2 from here, because we've both got even numbers and we need a third there. That makes sense. So it's going to be n over 3, and then it's going to be 4n squared minus 1, which is exactly what we want to show. So I put a little square underneath it. Great, right, moving on to part B. So that is for the series of 2n plus 1 up to 2n. So that's what makes this question difficult. We start at a number that's not 1 on the bottom, and we move up to a number that's not n on the top. So it's a little bit more tricky. We can use what we've done beforehand to simplify this for us though. What I'm going to do is I'm going to simplify this by doing a summation from 1 up to 4n. So I've added up too much here. So what I've got is a summation of substituting in things from 2n plus 1 up 4n, but I've accidentally also added in a summation of 2n down to 1. So that's what I'm going to have to take away. Take away this summation up to 2n, r equals 1, of 2r minus 1 squared. You can also remember it if you've got a 2r minus 1 plus 1 on the bottom of your summation, you need to take away 1 less than it on the other summation. Okay, so using the formulas now, I need to substitute in 4n into this formula up here, and then take away 2n, substituting into this formula up here. So it's going to be a third of 4n bracket 4 lots of 4n squared minus 1, take away a third of 2n times 4 lots of 2n squared minus 1. Now be really careful here where your brackets are. Make sure you're squaring the 4n, because eventually we're going to get 3 lots of 4n there. So expanding my brackets, I'm going to get 4 over 3n bracket 16 from the bracket, but times it also by another 4, so we get 64n squared minus 1. Take away 2/3 n of 2n squared is 4n times another 4, you get 16n squared minus 1. Okay, looking to factorise these terms now, so I have a common denominator of 3, and I could probably pull out 2 from both of these terms as well, from the 2 and the 4, and I've also got an n in both these terms as well. So what have I got left over? Well, I've got 2 lots of 64n squared minus 1, take away 16n squared minus 1. Make sure you've got your double brackets in here, because you're going to be taking away a negative, which is going to make it a positive. So 2 over 3n, and then in brackets 128n squared. Take away 2, take away 16n squared, add 1. So that's going to be 2 over 3n bracket, and then do the subtraction there, you get 112n squared, take away 1. And then that's what we've got for our answer. So we need to just therefore summarise. A is equal to 2/3, and B here is equal to 120. Excellent, 9 marks for that question.